In this video, we're going to be talking about some useful vocabulary for Unit 2. Our first word, integer. So an integer is a positive or negative whole number. If you look on this number line, these are all considered integers. Again, we have positives and their opposites, or all of our positive and negative whole numbers. These obviously continue to the right and to the left. Below are some examples of integers. 99, -2, -7, 8, 0, 46, -11, 32, and so on and so on. Our next vocab word is rational number. Rational numbers are the set of integers, including fractions and decimals. So these are some examples of rational numbers. Again, rational numbers include our integers, so -2, 10, 0. Those are all still considered rational. But then it also goes on to include all of the fractions or decimals in between those whole numbers. Absolute value. Absolute value is the distance between a number and 0 on the number line. So I have an image here. The absolute value of -3 is 3. It shows that it's 3 units away from 0 on the number line. The absolute value of 0 is 0 because it has no distance from itself. And then the absolute value of 5 would still be 5. It's 5 units away. So absolute value, it doesn't care which direction we're headed, if we're headed negative or we're headed positive. It just wants to know how far. How far did we travel away from 0? Additive inverse. Additive inverse, we can think add the opposite. Opposite numbers have a sum of 0. So looking at this problem here, our first term stays exactly the same, -2, but then we're going to add. We're going to change our subtraction to addition, and then we need the opposite of our second term. So in this case, -2 minus 4 would become -2 plus -4. Let's look at another example. 5 minus -9. Again, our subtraction becomes addition, and then we need the opposite of our second term. The opposite of -9 is +9. So our problem becomes 5 plus 9. We can think our double negative becomes a positive. Remember, you do not have homework. Would become positive and you would have homework. Multiplicative inverse. Multiplicative inverse, we think times the reciprocal. So a number multiplied by its reciprocal has a product of 1. Product is the answer to a multiplication problem. So what's a reciprocal? If I looked at the number 3, 3 is a whole number. How do I make it a fraction? Well, 3 is the same as 3 over 1. Any whole number, we can put a 1 underneath to make it a fraction. It's reciprocal. I'm going to switch the denominator with the numerator and the numerator with the denominator. So 3 over 1's reciprocal would become 1 over 3. Now, multiplicative inverses, if we multiply them together, will come out to 1. So 2 times 5 is 10, and 5 times 2 is 10. Well, 10 over 10 simplifies to 1. So any number and its reciprocal has a product of 1. Our next vocab word, distributive property. So distributive property would look like this. We have a number times a set of numbers being added together. We can distribute or give out the number being multiplied to each term inside the parentheses. So we have A times B, the first term, A times C, or the second term, and A times D. It has to get distributed to all terms inside the parentheses. So let's look at an example. Now, in this case, we could do 5 plus 7 plus 3, but this is setting us up for when we start working with variables that won't necessarily be added or able to add together. So first I would multiply times the first term, 2 times 5, and 2 times the second term. So 2 times 7. Remember, the dot means multiplication. And then 2 times the last term, 2 times 3. We then could simplify from here. So 2 times 5 is 10, 2 times 7 is 14, and 2 times 3 is 6, for a total answer of 30. Again, this is setting us up for when we start working with variables, so we have options if we have stuff inside the parentheses that cannot be combined. Associative property. Associative property of addition, again, who do you associate with? Who you associate with is like who you group yourself with, who your friends are. So think my grouping changed. My numbers stayed the same order. They didn't change order, just their grouping changed. Associative property of multiplication, same situation, only everything's being multiplied together. So if I multiplied B times C first, then times A, it would equal, or I would get the same answer as if I did A times B first and then times C. Let's look at an example. So if I was doing 2 times 4 times 3, 4 times 3 would have to happen first because PEMDAS, or order of operations, says we have to take care of the parentheses. This would be the same answer as if we grouped the 2 and the 4 together first. So let's do these both at the same time. 4 times 3 would give me 12. So I would still have my 2 times 12. Or 2 times 4 is 8, and then I still have my times 3. Remember, a number touching a parentheses indicates multiplication. We don't need a symbol in between. Now 2 times 12 is 24. Well, that's the same as 8 times 3. So if I change my grouping, my answer, or my product in this case, stays the same. Commutative property. So again, commutative property of addition, what changed here? A plus B plus C. Oh, my order switched. C plus B plus A. And we could change it to any order and we would still get the same sum. Commutative property of addition, same thing, only we're multiplying them together. So let's take a look at an example with multiplication. And remember, CO, change order. So 2 times 5 times 3 would give me the same product as if I jumbled up the order, 5 times 3 times 2. Well, what's 2 times 5? 10. And then I have to bring down that 3 that we didn't use yet. Or 5 times 3 is 15, and I bring down that 2 we haven't used yet. Well, 10 times 3 is 30, and 15 times 2 is 30. So changing my order doesn't change my product. Use this video to help you answer the questions on the back of your worksheet. Good luck.